Okay, the last time we have learned that if you have got two waves on, let's say, a string, one being a sine kx minus omega t, so it's going towards the right side, the other one being a sine kx plus omega t, so that's going towards the negative x, that is the left side, right? Then when these two waves superpose with each other, we get an equation of something called the standing wave. We get an equation of something called the standing wave, right? 2a sine kx cos omega t, where this part, the bracket here, is the amplitude of oscillations of different particles on the string. So you can see the amplitude depends on position, right? That is x coordinate. That's what we were talking about. That every point doesn't have the same amplitude, right? Every point does not have the same amplitude, right? Everyone remember that? Okay. So therein we found specific points. We found specific points where the amplitude is 0, right? What are these points called, everyone? What are these points called? Nodes, very good, right? They are called nodes. And nodes, again, nodes are those points that have amplitude 0. So when the string is oscillating, these nodes don't move at all, right? They do not move at all. Okay? They remain stationary just at that point. Okay? They don't oscillate. Well, now we are going over to the other kind of point. Alright? The antinodes. Also in the diagram we have seen that the distance between two consecutive nodes, again let's draw the diagram. Distance between two consecutive nodes is always lambda by 2, isn't it? You remember that, everyone? Distance between two consecutive nodes on that string is equal to lambda by 2. Okay, that is an important point, everyone. Don't take it lightly. Make sure you remember it. Okay, that's an important point. Alright, now let's go to the other side of this story. Number 3, antinodes. Right, let's talk about antinodes now. So what are antinodes? Antinodes are those points where the amplitude A dash is maximum. Clear? Antinodes are those points where the amplitude A dash is maximum. Alright? So have a look. We have earlier written that the amplitude A dash is equal to 2a sine kx. Right? It is equal to 2a sine kx. Now this should be maximum. This should be maximum. You know that if you look at different values of sine, then the maximum possible value of sine is 1. Right? Again, maximum possible value of sine is 1, maximum value. Okay? But even allowing minus 1 is going to be alright. Okay? Even allowing minus 1 will be alright. Because what that would mean, listen to this carefully. Even if the value of sine kx is minus 1, what it would mean is that instead of the displacement being in positive direction, it would be in the negative direction. I repeat, we know that maximum value of sine is 1, that is sine 90 degree, for example, 1, right? So if this is 1, very good, no problem, the amplitude, this bracket is maximum. But what if it's -1? Then also no problem. What that simply means is that the displacement of this particle, which is having sign kx as -1, will be towards the negative side. That's it. So here we can say that for antinode, sin kx can either be +1 or -1. Is this clear? Is this clear or not clear? Sin kx is +1 or -1. Okay. Right? So let's try to put that in form of angle. Okay, let's try to put that in form of angle. So let's go to the unit circle. Everyone, here is the unit circle. We want sine's value to be +1 or -1. Okay? So sine's value is +1 at this point, isn't it? And sine's value is -1 at this point. Clear or not clear? Sine's value is +1 at that upward point and -1 at the lower point. Okay? I am especially concerned about biology students. Okay? Math students, I am sure you know this. Fine? Clear? These 2 points, we are looking for these 2 points. Clear or not clear? Alright. Okay. So what are those angles? Here, if you start from 0 angle, this angle is pi by 2. Right? Then nothing for pi, 3 pi by 2. See, first angle is 1 pi by 2. If you start from here. Okay, pi by 2, 3 pi by 2. Go further, 2 pi. And plus pi by 2 means 5 pi by 2. Again, simple idea. One quadrant means pi by 2 angle, correct? So from here 0, 1 pi by 2, yes. 2 pi by 2, no, nothing. 3 pi by 2, yes. 4 pi by 2, nothing. 5 pi by 2, yes. Clear or not clear? After this 6 pi by 2, nothing. 7 pi by 2, yes or no? All these angles are clear. That here we will get sin kx equal to +or -1. Angles are clear or not clear? Angles are clear? Okay? Now, this is all generalized like this. I am sure in 10th standard you have studied this. If you want to write odd numbers 1, 3, 5, 7, 9, 11 and so on, then we can write them as 2 into n minus 1. Is that okay? Odd number 2 into n minus 1 where n is integer. Right? Where n is integer. Okay or not okay? Right? So 2n minus 1 pi by 2, that should be kx. Raise your hand if you understood this step. Raise your hand if you understood this step. Okay. Again, odd number. See, you can try. Put n equal to 1. 2 into 1, 2. 2 minus 1, 1. 1 pi by 2. Put n is 2. 2 into 2, 4. 4 minus 1, 3. Like that. Okay, so kx is 12 minus 1 pi by 2. But what is x? 2 pi, what is k? 2 pi by lambda, isn't it? We know that k is 2 pi by lambda. So if we put it there, pi cancelled and we get x equals 2n minus 1. Lambda on that side, pi is cancelled, 2 divided here, so 2 into 2, 4. Okay, 2n minus 1, lambda by 4. Alright, this is the value of x for antinode. This is the value of x for antinodes, right? Now let's just do one thing back. Let's put n as integers here, right? N is integer, so let's start with 1. Remember, we started with 1 here. So if I put n equal to 1, first antinode is at x equal to lambda by 4, okay? Second antinode will be at x equal to 3 lambda by 4, okay or not okay? How 3 going to do 4? 4 minus 1, 3. 3 lambda by 4. Third antinode would be at x equal to 5 lambda by 4. Alright, all of this is clear, and so on so forth. Okay? Now let's draw that in our picture. Here. So, first one is at which distance? X equal to lambda by 4. See, this is x equal to 0, this is x equal to lambda by 2. And here we want lambda by 4. So, half of that. Did you understand this first antinode A? Yes or no? Did you understand the first antinode A? Okay? No સમજાણું અઘરું પડ્યું આમાં? x equal to lambda by 4 ક્યાં આવે? This is x equal to lambda by 2. So where is x equal to lambda by 4? On the string. It will be halfway between the two, right? Okay? Then, what about this one? 3 lambda by 4. Okay? 3 lambda by 4 means 0.75 lambda, isn't it? 3 by 4, 0.75 lambda. So, 3 by 4 lambda will be here. Think about it. Exactly between lambda by 2 and lambda. What is midpoint of lambda by 2 and lambda? This is the midpoint of lambda by 2 and lambda. Yes or no? Yes or no everyone? This is the midpoint of lambda by 2 and lambda. How much will that be? Take LCM. You get 3 lambda by 4. Clear? Clear or not clear? So, where is the second antinode? It's here. So, are we noticing a pattern? The pattern is that between two nodes, we are getting antinode. Clear? Between two consecutive nodes, we are getting antinode. Understood or not understood? Between two antinodes, we are getting, between two nodes, we are getting an antinode. Clear? Okay? This will continue, of course, till as many as there are. So this will be the third one and so on and so forth. Understood the location of nodes and antinodes? Okay? Another interesting thing, everyone. Another interesting thing. What is the distance? What is the distance between two consecutive antinodes? You understood my question? What is the distance between two consecutive antinodes? What do you think? Yes, neighbors. You can also find how many antinodes are present. There is nothing complicated about that, right? Just like we found nodes in the morning, you can find antinodes also by using either maths or simple diagram. I prefer the diagram way. Nothing can beat the diagram method. Okay, forget about complicated math. Just diagram and you get the answer. Okay, so the correct answer, as many of you have said, is lambda by 2. Let's write it, everyone. Let's write it here. Let's write it. Distance between two consecutive antinodes. Distance between two consecutive antinodes is how much? Always lambda by 2. That is half of the wavelength. Clear? Not lambda. Lambda by 2. Right? This is lambda by 2. Okay, right? This is at midpoint of this, and similarly this is lambda by 2, it's at midpoint, so this distance has to be lambda by 2, right? Okay, just be a little bit careful, that's it, right? Further, one more thing. For antinode, so these are some nice or important or worthy to remember points. For antinode, the amplitude of oscillation is maximum. Of course, this is the definition of antinode, right? For antinode, the amplitude of oscillation is maximum and A dash equal to 2A. Did you understand? 2A. See, not A. That's the deceptive part. A dash equal to 2A. Clear or not clear? Not A. It will be 2A. Alright? A dash will be 2A. For what point? For antinode. Huh? Don't use that for every point. Only for antinode, A dash is equal to 2A. Okay? Right. Let's go to the next point. We are going to come back to the role of minus 1. We will come back to the role of that minus 1. Okay, have a look. Have a look, everyone. Be careful now. Trigonometry and physics going to merge over here. Let's see. First of all, let's say that we look at this antinode. Okay, let's call it A1 and let's call this A2. Okay, so we can communicate easily. Suppose I am calling this A1, that is first antinode, and I am calling this A2, that is the second antinode. So, do you realize that for A1 we have kx equal to pi by 2 or 1 pi by 2. Is this clear? Why so? You start from here and you go to here, so you get maximum value of sine. Yes or no? Kx equal to 1 pi by 2. Yes or no? 2a not clear? Come on, they work. 2a is not clear? I am surprised. A dash is 2a sine kx, isn't it? A dash is 2a sine kx. Then what do you do? This sine kx we put maximum value 1. Then what do we get? What do we get? Okay, I hope now it is clear. So for A1 kx is 1 pi by 2. Okay, now let's talk about A2. So for getting to A2, we have to go all the way till here, right? So we get kx equal to 3 pi. Now what this means is that here sin kx is plus 1 and here sin kx is minus 1. Is all this clear? Whatever I have written on the board, is it clear or not clear? Why minus 1? Going to this point here, right? Okay, plus 1 and minus 1 clear. Plus 1 for pi by 2, this point, and minus 1 for 3 pi by 2, this point. Okay. Now, if we will write the equations at any time t, y1, okay, so that is displacement of A1 will be, okay, displacement of A1 will be, I am writing it as YA1, okay, displacement of A1 will be, let's use the formula, 2A sin kx cos omega t. Yes or no? This is the formula for the standing wave which we are talking about over here, right? Y equal to 2A sin kx cos omega t. So let's put this here. So do you realize that this will become 2A cos omega t? Yes or no, everyone? Is that clear or not clear? Now let's go for the other one. Okay, so similarly for y2, I mean a2, displacement of a2 at that time. At that time means what? At time t. Okay, at time t. So y of a2 will be 2a minus 1 cos omega t, that is equal to minus 2a cos omega t. Clear so far? Is it clear why I have written minus 1 here? Because sin kx is minus 1, right? Sin kx for this point is minus 1. Okay. Now, if that is minus 1, what this means is, now if you look at these equations, they look like opposite of each other. Obviously, they are opposite of each other, of course, right? But there is one more way to write this. Okay, I can write this as this. Okay, basically I have used a trigonometry formula. Okay, just give me 1 second. I lost my pen. Yeah, here it is. So the formula is as follows. We have mentioned it earlier. This is just a repeat. Cos theta plus phi is minus cos theta. Okay, cos theta plus phi is minus cos theta. Right? I'm sure math students know that already. Right? So this is only probably new for biology students. Even then, it's very easy to understand. So far I'm not trying ever explaining trigonometry formula to you, but now I am confident you will understand. Suppose there is some angle theta. You are here. This is x coordinate, y coordinate. X coordinate is cos. Do you remember that? Everyone, do you remember that? Yes or no? Yes or no? Okay, now if you will take angle which is more by pi that is 180. So instead of going on this side, it will go all the way here. Then do you realize that this point will be minus x minus y? Yes or no? If this is xy, this will be minus x minus y. Yes or no? Okay, what does that mean? What does that mean? That when you take the angle as cos theta plus phi, the x coordinate becomes negative. Yes or no? Clear? The x coordinate becomes negative. And that is why we have this formula. I hope you understood that formula now. Okay? Of course, every trigonometry formula has some reason, but like I said, every time I don't go into it, right? Otherwise, we'll be learning only trigonometry and no physics. Well, so is this step clear now? Have a look. Is this step clear? Okay, what does this mean? This means that if you compare YA1 with YA2, there is a phase difference between them. Do you remember phase difference? What is the meaning of phase difference? This angle is called phase, isn't it? The angle that we write here in bracket is called phase. So what is the phase difference between A1 and A2? What is the phase difference between A1 and A2? Everyone, what is the phase difference between A1 and A2? Ami, you can find it exactly. Even from here you can find it, or by the formula that you have written you can find it. How much will be the phase difference between A1 and A2? How much will be the phase difference between A1 and A2? Yes, Aditya, that's correct. Correct, Ankita. Others, come on, is it that tough? Arey, how to find phase difference? This is angle and this is angle. They are called phases. What is their difference? આટલું સિમ્પલ પૂછ્યું હતું. What is their difference? That is called phase difference. આ કોણ છે 0 1? 0 કેટ આવે હે? Difference between these two is 0. Think about it. Definitely the difference between these two is pi. Clear or not clear? Difference between these two is pi. Clear or not clear? Okay? Everyone, is this understood? Fine. Right. So, what we have learned, we are going to write it here as the third point. Okay, I am erasing these 2 points. Remember, the points that I make you write, they are worth their weight in gold. They are very, very, very important. Before exam, if you just read these points, you will definitely be able to solve the questions. Right? હું તમને નકામું કંઈ જ લખાવતો નથી, બરાબર? જે માં સ્ટાર્ટ કર્યો એટલે સમજી લેવાનું કે ડાયરેક્ટલી ક્વેશ્ચનમાં યુઝ થશે. Okay, now the third thing about antinodes is that consecutive antinodes have phase difference. Consecutive antinodes have phase difference pi or 180 degrees. There is another way to understand also. Even then the maths is necessary. Let me tell you that this maths is important. Okay, for one more purpose. You could have done this directly using this also. Phi equal to 2 pi by lambda into delta x. Do you remember this? Like you were suggesting, Ami. Clear or not clear? Okay or not okay, everyone? So આમ નહીં તો આમ તો આવડી જવું જોઈએ હતું, because we have done this thing earlier. Okay? But still, these equations are going to help us little bit later. Right? These equations are going to help us. That's why we needed to write them anyway. So, what we are seeing is that these equations tell us that when one antinode, that is A1, has positive displacement, whatever that is, the second antinode has exactly the same negative displacement. You understand what I am saying? That these two are negative of each other? Yes or no? What I am saying is that YA1 and YA2 are opposite of each other. Yes or no? Is that clear? अरे અહીંયા જોજો, બીજે ક્યાંય ન જોતા. That's simple. Clear or not clear? These two are negative of each other. Okay, what does that mean? Physically, what does that mean? Listen to this carefully. What this means physically is that when this point is oscillating, let's say A1 point is oscillating, this is the mean position line. Again, remember these are transverse waves. Remember these are transverse waves. So, what will happen? These points will oscillate vertical. Okay? Right? So, what does that mean? Suppose at some time this point of the string has risen up like this. Okay? Suppose at some time the point A1 has risen up like this. Then at the same time the point A2 would go down by the same distance. Did you understand? If this goes up by some distance, this will go down by the same distance. Clear or not clear? Clear or not clear? Okay, fine. What about next point? If this goes up, this will go down, then this one will go up at the same time. Yes or no? Yes or no? Okay. So what will string shape look like? When this goes up, this is node, they don't move. So did you understand this string shape? Did you understand this string shape? Yes or no? Okay. Further, this point has come here. So here the string shape is going to be like this. Again, this is a node. Right? Third, like this. Okay? You might say, sir, this is not new. You already knew this. No. No. You don't know this. This is not a traveling wave. That is, this pattern will not move forward. No, not a traveling wave. It's a standing wave. This is not a traveling wave. This pattern will not move forward. Like I explained at the start, if you remember. Right? Instead, what will happen? What will happen? All these points are oscillating. So, this has gone up. You know, if something is doing vertical SHF, from mean position it will go up, then it also has to come down, then it will go up again. Yes or no? Yes or no? Do you realize what I am saying? This point has gone up, then it will also come down. Correct or not correct? Okay? So, do you realize after some time, this point A1 will come back to mean position. Why will it come back to mean position? Because it is oscillating. If something is oscillating, it must come back to mean position. So, what will happen when this comes back to mean position? The string will become flat. String will become flat. Similarly, if y(a1) is 0, y(a2) will also be 0. So here also the string will become flat. And here also the string will become flat. The whole string will become flat. And then suddenly, when this goes down, the string shape will become like this. Did you understand? Clear or not clear? But when A1 goes down, A2 will go up. Okay or not okay? And A3 will go down. And A4 will go up. Like that. Did you understand what I am saying? Did you understand what I am saying? Okay, time to see it for actual. Okay, time to see it for actual. Just give me one moment, everyone. Okay, hopefully you can see the video, right? Okay, I know you can't hear the voice yet, just give me 1 minute. I'll turn on the voice. Can you hear the audio, everyone? So, okay, can you hear me now? Alright. So, what are we seeing here? We are seeing a standing wave that has been set off on this string, right? We are seeing a standing wave that is created or has been created on this string, right? So let's start from the beginning. Can you hear audio, everyone? No? Can't hear audio now? Okay. Okay. So do you hear? I mean, do you see the standing wave here that is set up, right? Right now nothing is happening. Okay. Can you identify nodes and antinodes? Can you identify nodes and antinodes clearly in this diagram? I mean in this picture actually. Okay? This point is antinode. Okay, green ones are antinodes. Is that clear or not clear? Because there you can see the string is vibrating maximum. There the amplitude is maximum. But if you look at the red one here, this is a node. Here the string is tied, it's a node. And here the string is tied, it's a node. Did you understand? Okay, right? Also don't think that string is converted to something fuzzy. It's not like that. At the present moment, this is where the string actually is. I'm trying my best to draw, please excuse me. The string is, oh sorry, like this. Did you understand? So like I was saying, when A1 goes down, okay, come to the board, everyone. Come to the board. When A1 goes down, A2 will go up. That is the phase difference between them is pi. I repeat, when A1 goes down, A2 goes up. That's what you are seeing at this moment. Clear or not clear? Okay, let's continue playing this. See, he is actually holding that point, and still it doesn't affect anything because anyway that point was not moving, it's a node.
So node is not moving. Here it's moving up and down, here it's moving up and down.
So now this is the same thing shot by a high speed camera, okay? So here you are going to see how the string is actually oscillating. Like I said, when one antinode will go up, the neighboring antinode will go down, and then the next one will go up, and vice versa. Okay? Do you see that? A1 going up, A2 going down. Yes or no? See, right now A1 is down, A2 is up. Now, here A1 is up and A2 is down. So they are always going to be opposites of each other. Is it fine? Okay, now we are going to increase the frequency. If you increase frequency, wavelength will decrease, right? So let's see what happens.
Now, like I said, second one, what's the first one? The first one will be half this. So 8.5.
He's still doing it, just one. Okay, he has decreased the frequency. I'm so sorry. This is a case with decreased frequency and more wavelength. Here there is only one antinode. Do you understand what I'm saying? There is only one antinode. Yes or no? Where is the one antinode? At the center. Right? Okay? Here, somewhere here, right? Yes, the nodes are at end point. Okay? This is where the node will be, and this is where the node will be.
Now, I can find any of the other, all of the other harmonics are multiples of this number. So we just saw 2 times this number, the second harmonic, the second harmonic. Well, 3 times this number.
So now he is going to increase the frequency. Okay, so what he counted is, let me just clarify. So suppose you think of node here, right under his mouth. This is one node, this is another node, and here is one more node. Okay? What's the distance between two consecutive nodes? It is lambda by 2. Okay? So that way the total length of the string L is equal to 3 lambda by 2. Alright? Okay or not okay? Viewers, you can go out of the meeting and come back. You might be able to see it. Okay. So that's what we have. Again, if you remember, in the morning we derived. Okay, I'm writing on the board. L is equal to n lambda by 2. Do you remember? We derived that L is equal to n lambda by 2. Right? So that's what we are seeing here. N is equal to 3 lambda by 2 because 3 loops are formed. Do you see loops, everyone? Because I'm going to talk a lot about loops now. Okay? 3 loops. We can do this even further. You know, it's not like we can do it only for 3 loops. Okay? Let's see it further.
It's easier to see high speeds. Check out this shot with high speed camera. Verify for yourself.
Do you see what is happening? Can you spot the nodes? Can you spot the antinodes?
So, again, further on, what the hell? Let's go to the 6-part one.
So now he's going to double the frequency, so there will be 6 loops.
There we go. That's the 6-part one.
Okay?
And it's 6 times the fundamental frequency, which we measure beginning with 8.5 hertz. So, check this guy out. We have 1, 2, 3 wavelengths.
3 wavelengths. 6 lambda by 2. Basically he's saying 6 lambda by 2. Okay? Fine, so that's it for today's class. Goodbye everyone.